Good morning. We will talk today about transformation, constructions, congruency and similarity. Well, transformations are sometimes called mappings also. Transformation is to move a geometrical object from one place to another place. So, this triangle ABC is moved to another place A dash, B dash and C dash. This movement of geometric object from one place to another place is what we call transformation or mapping. And in this situation we say the point A is mapped to point A dash, and similarly point B is mapped to point B dash, and point C is mapped to point C dash. And A sometimes this A dash is called corresponding point to the point A. A and A dash, they are corresponding points. Similarly, B and B dash, they are corresponding points. C and C dash, they are corresponding points. A corresponds to A dash, B corresponds to B dash and C corresponds to C dash if this triangle ABC is moved into another location and we are renaming it A dash, B dash and C dash. And well, as I said, the point A is corresponding to A dash, B is corresponding to B dash and C is corresponding to C dash. Then we will get corresponding angle. So, the angle A corresponds to angle A dash. So, this angle corresponds to this angle. Similarly, the angle B corresponds to angle B dash and angle C corresponds to angle C dash. Moreover, by corresponding sides we mean AB is moved, AB is transformed from one place to another place and it became A dash, B dash. So, AB is AB and A dash, B dash are said corresponding sides. Similarly, BC and B dash, C dash are the two sides are corresponding sides. Now, we have a concept in geometry, and that concept we will be using this vocabulary so frequently. We have a concept of congruency. So, congruent polygons, two polygons are congruent if and only if there is a mapping from one to the another. That means we can do a transformation of one polygon into the another polygon such that corresponding angles are congruent and corresponding sides are also congruent. So, if we have two polygons, their sides are congruent, their angles are congruent, then we say the triangles are congruent, or sorry, polygons are congruent, and we represent congruency using this symbol equal to and that sign on the top of equal to. This sign represent congruency. So, by saying two triangles are congruent, we mean this. Let us say this is a triangle ABC and let us say this is another triangle XYZ. Suppose angle A is same as angle X. Suppose angle B and angle Y, they are congruent. That means they have the same sides, and let us say angle C and angle G, they are congruent. So, the angles of this triangle are congruent to angles of that triangle. So, the first criteria is satisfied, and furthermore, suppose this side AB is the same as XY, and let us say the side BC is same as YG and side AC is same as XG. They are congruent means the two sides are said to be congruent if their lengths are same. So, if the side AB is congruent to XY, side BC is congruent to YZ, and side AC is congruent to XZ, then these two triangles we call congruent triangles, and we write triangle ABC is congruent to triangle XYZ. So, this is an example of congruent triangles. We can have congruent quadrilaterals, we can have congruent pentagons, we can have congruent hexagon, heptagon. We can use the same concept of congruency for any kind of polygons. Okay. So, the next concept we want to talk is regarding construction. When we are talking about construction in geometry, constructing things, in order to construct things, we use the ruler and the compass. So, by construction here, I am saying constructing line segments and angle by using ruler and compass. So, let us say we want to construct a line segment congruent to this given line segment. Suppose AB is a given line segment, we want to construct another line which is congruent to AB. Congruent to AB, two lines are congruent if they have same length. So, basically we are trying to construct another line whose length is the same as AB using a ruler and a compass. In order to construct a line congruent to a given line, we draw a long line using a ruler, and we will select a point here. This is a long line, draw a long line using a ruler and select a point here. Let us say this point is P. We are naming the point to be P, and now we will be using compass. So, we know the compass. Using compass, we will put one end of the compass at B. We will put one end of the compass at B and open the compass so that the another end will go at A. So, we are putting one end of the compass here and the another end of the compass at B. So, this much will be the opening of the compass, and with the same opening of the compass, we will put one end of the compass here and the pencil end will go here and draw an arc here using that compass. Using that compass with the same opening, we will draw an arc here, and let us say the arc meets the line at Q. So, this line PQ now, the line PQ, if we construct this way, will be congruent to the line AB. That is how we use compass to construct a line congruent to any given line. Okay, now constructing angles. In order to construct an angle congruent to, let us say, this angle, we are trying to construct an angle congruent to this angle ABC. We are trying to construct an angle which is congruent to this angle B or angle ABC. Okay, in order to construct an angle congruent to B using ruler, we will draw a straight line and mark a point. Let us say we will label this point, let us say this point is P. Okay. Once we mark the point, now we will be using our compass. So, using our compass, what we will do is we put one end of the compass here, and with the pencil end of the compass we will draw an arc like this. We will draw an arc like this, and with the we will draw an arc like this, and with the same opening, without changing the opening of the compass, we go at point P, put one end of the compass at P, and with the pencil end draw another arc, a long arc here. Okay. So let me repeat. Using your compass, you will put one end of the compass at B and draw an arc crossing this line AB and AC both, crossing AB and AC both. And using the same opening of the compass, the same size on the compass, we put one end of the compass at P, and using the pencil end of the compass, we will draw an arc like this. Okay. Next, using our compass, we will put one end of the compass at this point on the line BC, and we will change the opening of the compass so that the other end of the compass will touch this point on AB. So, we will be measuring this much from here to here using compass, from this point to this point using compass. We will measure this point to this point using compass, and using the same opening in the compass, we put one end of the compass here. We are using the same opening, and we will draw an arc crossing this previous arc like this. Suppose these two arcs are intersecting at this point. We will note this point where the two arcs are intersecting and connect this point with this using our ruler. So, this will be what this angle now. Let us say this is P, this is Q, and let us say this is R. The angle PQR, the angle PQR will be of the same size or will be congruent to angle ABC. That is how we construct congruent angles. Okay. Now, constructing triangles. Once we know how to construct congruent lines and how to construct congruent angles, those two concepts, using those two concepts, we can construct triangles. So, here in this example, we are trying to construct a triangle. We are trying to construct a triangle whose sides are congruent to three given line segment. So, this is one line segment. Let us say this is AB. Let us say this is PQ, and this is CD. We are given three line segments. We are trying to construct an angle. We are trying to construct a triangle whose sides are congruent to AB, congruent to PQ, and congruent to CD. By sides being congruent means the length are equal. So, we are trying to construct a triangle length of whose sides are equal to AB, PQ, and CD. So, in order to do that, using our ruler and compass, this is what we will do. We draw a line segment, or we can draw a long line and label a point. Let us say this point is X. Now, from X, draw a line congruent to AB, or you can put your one end of the compass at A and measure the length of AB using compass. And using the same opening in the compass from this point X, we will put one end we will put one end of the compass at x and draw an arc, and let us say this is y. Now, this x y will be congruent to AB. Okay. Now, using our compass, we will measure the length of PQ. Using the compass, measuring the length of PQ means put one end of the compass at P and change the opening and make sure the another end overlaps at Q. So, we have certain opening of the compass. With that opening of the compass, we go here, put one end of the compass at Y and cut an arc here using the same opening. So, now any point on this arc, if we join that with y, the length will be equal to PQ. Anyway, now we use our compass to measure the length of the CD. As before, in order to measure the length of the CD, we will put one end of the compass at C, change the opening so that the another end will go and overlap at Q. And once we have that opening, we will bring the compass at X and draw an arc like this. Bring a compass at X and draw an arc like this. So, this arc previously drawn from Y and this arc now drawn from X, they will meet at this point, and let us call that point a G. Now, if you connect X and G and Y and G, we have a triangle now, triangle XYZ, and this triangle will be congruent to the triangle whose sides are AB, PQ and CD, because XY will be equal to AB, YZ will be equal to PQ and XZ will be equal to CD. Well, this construction of triangle with three given sides is based on a very famous fact about triangles, and that fact is called SSS congruency. S stands for side. So, this fact is called side congruency, and this fact says if three sides of a triangle are congruent to three sides of another triangle, then the two triangles are congruent. We have one triangle, we have a second triangle. If three sides of this first triangle are congruent to three sides of the second triangles, the two triangles has to be congruent. That is what SAS congruency says. Meaning that if I have a triangle here, let us say ABC, and let us say I have another triangle XYZ, let us say I have another triangle XYZ, if AB is congruent to XY, AB is congruent to XY and BC is congruent to YZ and AC is congruent to XZ, then in this case we say these two triangles are congruent. Now, well, we looked at an example of constructing a triangle with three given sides. When the three sides are given to us, we know how to construct a triangle using the three sides. However, the truth is it is not possible, it is not always possible to construct a triangle with three given sides. So, for example, let us say somebody tells us construct a triangle with sides, let us say 1, 1 and 3. Let us say one side is 1 centimeter long, the second side is 1 centimeter long and the third side is 3 centimeter long. If This is what the requirement. With this requirement, no triangles can be constructed. We cannot construct a triangle whose one side is 1 centimeter, the second side is 1 centimeter, and the third side is 3 centimeter. And the reason we cannot construct a triangle with this dimension is we have a very popular fact in geometry called triangle inequality. According to this triangle inequality, the sum of the length of any two sides of a triangle is greater than the length, should be greater than the length of the third side. If we add length of two sides of the triangle, the sum has to be greater than the third if we have a triangle. If we look at this given length, if we add this first side 1 with the second side, which is also 1, 1 plus 1 has to be greater than the third side, which is 3. And we know that 2 is not equal to 3, so this is not possible. That means we cannot construct a triangle with this given dimension. However, we can construct a triangle with, let us say, one of the side is 2, another side is 3, another side is 5. Well, let us say another side is 2, 3, 4, let us say. Then if we add 2 and 3, we get 5, which is bigger than 4, good. If we add 3 and 4, which we get 7, which is bigger than 2, good. If we add 2 and 4, which is bigger than 3, good. So we can construct a triangle whose sides are 2, 3 and 4 because this number 2, 3 and 4 satisfies the triangle inequality. We cannot construct a triangle whose sides are 1, 1 and 3 because these three numbers does not satisfy the triangle inequality. There are other congruency rules regarding triangle. We already looked at side congruency. The second congruency rule for congruent triangle says this: if we have a triangle, let us say ABC, and let us say we have another triangle X, Y and Z. Well, as I already mentioned, this S refers to side, A refers to an angle, and S refers to another side. So this SAS congruency says this: suppose we have two triangles. Let us say this side AB of this triangle is congruent to this side XG of the second triangle. One side of one triangle is congruent to one side of another triangle. Let us say this angle of first triangle is congruent to this angle of the second triangle. So I am saying A is congruent to G. And let us say this side AC of the first triangle is congruent to YG or GY of the second triangle. Now you see, one side of this triangle is congruent to one side of this triangle, another side of this triangle is congruent to another side of the triangle, and most importantly the angle in between these two sides, angle formed by these two sides, the angle in between these two sides, angle has to be in between the two sides. Two sides, they are congruent. If the angle in between are also congruent, like A and G are congruent, according to this SAS congruency, these two triangles will be congruent. So two sides are congruent, angle in between is very important, the angle in between is congruent, then the two triangles are congruent. Another congruency is called ASA congruency, and ASA congruency says this. Suppose we have a triangle ABC and we have another triangle, let us say X, Y and Z. Let us say this angle of this triangle is the same as this angle of the triangle. A and X are congruent. A is for angle, S is for side, and the side, let us say this side and this side are congruent. And let us say this angle and this angle are also congruent. Look, we are thinking of angle, then side and this angle. The side, in this situation, the side has to be in between the two angles. We cannot apply ASA congruency if this side and this side are same. This side and this side, they are not in between the two angles we are considering. So, if two angles are equal and the side in between them are also equal or congruent, then these two triangles are congruent. This fact, this congruency rule is called ASA congruency. Okay, so we have three different rules of congruency: SSS, all three sides; SAS, two sides and angle in between them; and ASA, two angles and the sides in between them. Okay. Now, let us look at some other construction. Suppose we want to construct bisectors. Suppose we want to construct bisector. So, the first example we will be looking at perpendicular bisector of a line, and the second example we will be looking at angle bisector. Bisector means it's to divide into two equal half, and perpendicular bisector means we want perpendicular. So, let us say suppose this line is given to us. Let us say AB is a line and we want to construct a perpendicular bisector of AB. AB is the given line, we want to construct perpendicular bisector of the line AB. In order to do that, again we will be using our compass. What we do is put one end of the compass at A, put one end of the compass at A and open the compass so that the opening of the compass is bigger than half, it should be bigger than half of length of AB. So, have large enough opening, should be bigger than half of length of AB. So, put one end of the compass here and with the opening which is bigger than half of length of AB, draw an arc here and here as well. So, we will put one end of the compass here, draw an arc over there and draw an arc above AB and one arc below AB as well. It is better to draw a longer arc. If we have a small arc, we probably will not achieve what we want to achieve. So, when drawing those arc, make sure we draw long enough arc. Now, use the same opening in the compass. Do not change the opening of the compass. Put one end of the compass here and with the pencil end of the compass, draw another arc like this. And with the pencil end of the compass, draw another arc here like this. The two arcs, one coming from A and another coming from B, should intersect, and we should not be changing the length of opening up in the compass. So, now let us say this point is P and let us say this point is Q. Connect the line PQ using a ruler. This PQ, now constructed this way, is perpendicular. This is the perpendicular, it will be perpendicular to AB, bisector of AB. So, the line constructed PQ, the line constructed with applying this technique will be always perpendicular bisector of the given line. Next, we want to construct bisector of an angle. Suppose this angle, let us say this angle A, B, C is given to us, and we want to construct bisector of this angle ABC. In order to construct bisector of this angle ABC, again we will be using compass. Put one end of the compass here and draw an arc cutting the line AB and BC both. Draw an arc so that that arc will intersect AB and BC both. So, let us name them X and Y. Let us name them X and Y. Now, put one end of the compass here at X and draw an arc. Put another end of the compass here at Y and draw another arc. Let us say this point where the two arcs drawn from X and Y intersect is, let us say this point is a D. Join a line connecting A and D. That line AD, this line AD will be the perpendicular, not perpendicular, line AD, this line will be the bisector of AB. So, in this situation AD is the bisector of angle A, angle BAC I should say, or let us say just simply angle A. Okay. This is how we construct angle bisector. Now, the next thing we want to know is how to construct perpendicular to a line through a given point and how to construct a line parallel to given point. So, how to construct a line which is perpendicular to a line through a given point, not in the line. So, basically the first construction refers to constructing a line parallel to given line and perpendicular, construct a perpendicular to a given line through a point not on the line. So, basically this is what we want to construct. Suppose this is a given line, let us say AB is a given line. We want to construct perpendicular to AB from another point, let us say C. So, we are given a line and we are given a point, we are trying to construct a perpendicular from this point C onto the line AB. Okay. What we do is we put one end of the compass at C and open the compass so that and draw an arc cutting AB here and here. Putting one end of the compass at C, we draw arcs cutting here and cutting here, one towards A, one towards B. Let us say this point is X, this point is Y. Now, we put one end of the compass here and draw an arc like this below the line AB, and put another end of the compass and draw another arc like this here. Like this here. Well, if we do that, then let us say this is our point C. if we connect this intersection, let's say D, let's name it D, if we connect this to this line will be perpendicular to AB. So, in this situation CD will be perpendicular to AB. Okay. Okay. So, let us look at another construction. So, we will be constructing a line parallel to a given line through a point K that is not in it. So, basically we are given a line, let us say this is a given line and let us say this is a given point, call it K. We want to construct a line that will pass through K and will be parallel to this given line. So, we are trying to construct a line which will go through K and will be parallel to this given line as well. In order to do this, what we do is we use compass, put one end of the compass at K, and with another end draw an arc cutting this line, let us say somewhere here, and let us name this point to be X. Now, with the same opening of the compass, we come here at X and draw an arc cutting this line, let us say at Y. With the same opening in the compass, from Y we will cut an arc this way. One end of the compass is at Y and the arc using the pencil end is here. Now, with the same opening we will come and put one end of the compass here and cut this arc this way. We are putting one end of the compass here and drawing an arc like this. Let us say the arc coming from Y and X meets at this point. Let us say this point is P. If we join this K and P, and if we draw a line joining K and P like this, this new line will be parallel to XY. So, if we draw a line like that, we can say XY is parallel to PK. Okay, these are bunch of different construction we can do by using compass and ruler. Try various construction similar to this construction using examples in the book, and let me know if you have any question. Thank you for watching. Have a good day.